Okay, so let's take a look at the first question for today's quiz, the practice quiz that is. Here's the items that we're looking for: the order, the rate expression, the overall order of the reaction, as well as the value for K, or the rate constant. The last thing we're going to be asked to do is what is this initial rate given these concentrations. We'll be able to do that once we have determined what K is through our rate expression. Now, the first thing we want to do is write out a generic expression. Okay, so rate K equals A to the X, B to the Y. And these are our order statements. Okay, we're going to do this one of two ways. The first one here, we can do via just inspection, okay, by looking at holding one thing constant and doubling or tripling or quadrupling the concentration of the other one. So the first thing we're going to do is I'm going to look for some easy ones. I'm actually going to hold this one constant first and look at this one. So I'm going to look at a couple of options. All three of these are constant. And if I want to do this by inspection, I really want to look at B, where it doubles. So I'm going to pick experiments number 2 and number 5 because 5 is half the amount of 2. So between these two here, I see that I double the concentration of B. So this is really used to determine the order for B, because if I have a change in rate, that is going to be attributed to the change in concentration of B. So I'm really creating whatever this order is based on this change. Because this is held constant, the concentration of A shouldn't change the concentration or the initial rate of this reaction. So I see this doubling, and when I compare these two, what happens to my rate? It also doubles. Okay, so here's our statement. Okay, concentration of A stays the same, concentration for B doubles, therefore the rate doubles, and this is a first order reaction. Okay. Now I'm going to look at the next one, but I've got to look at and compare things where I keep B constant. So B is over here on the right side, and I'm going to look at which ones over here stay constant. So I've got this one here and this one here. Those are the only two that I have that stay the same, so I'm going to compare. Let's see what I have here. Okay, ooh, that's good. Because look at this. I've got B held constant, so that means whatever change in rate is going to be attributed to our A. And so when I look at my A, I'm going from 0.12 concentration to 0.240, so I'm doubling my concentration. Let's see what happens because I double that. All right, I go from 0.150 all the way up to 2. Okay, so 0.500, that's a multiplier of 4 to get up to the 2. All right, so in this case, I've got a little bit different statement. Okay, I'm keeping B the same at the 0.120. Okay, A is doubling, and the rate responds by quadrupling. Okay, oops, yep, quadrupling. All right, therefore this is a second order in regards to A. Put a little 2 up there. Okay, from there we can write our rate expression. Okay, so rate equals K times A to the second, B to the first. One of the questions they ask is what are the units? The easiest way to do that is to put in the units for each one of these and solve, rearrange. Okay, so here's our units for rate. Okay, that's what we're solving for. This is moles per liters, and we need to make sure that we're squaring it times moles per liters. Okay, and so here's the work where we have isolated K. Okay, multiplying by the inverse, liters over moles cubed. Okay, and we end up getting a K value of liters squared, moles squared per hour. This one was a tricky one because you had to catch this in the units on here. Okay, usually that is, we've seen that listed as second, but here time is listed as hours, and that's 100% okay. Okay, so we've done most of this problem already. The last thing we need to do is determine what our K value is. Okay, and so here's our rate expression. Okay, we have our rate expression, rate equals K times A squared B times B, and You can pick any experiment. I picked the data from experiment 4. The rate was 0.500 and the concentration was 0.12 for A and also 0.120 for B. I chose that because it makes it simpler math. And then our K equals the 289. 3 sig figs here because it actually is 289.345 or something like that. And then our units are attached to it. Okay, so there is K. The last thing is we want to determine what this initial rate was. Okay, well, I have these two concentrations and I have K, so all you have to do is put your concentrations in. Make sure you square this for the A, the second order for A, multiply by 289, and your rate is 0.0764 moles per liters per hour. Okay, so pretty straightforward. Okay, hopefully that was helpful. I will actually scan these in and you can take a look at the work on there. Hopefully that helps you.